Welcome back, everyone. If I was to summarize the past two videos from this chapter so far, it would be with this one sentence that's at the bottom of this slide, which is that 1 mole of anything is equal to Avogadro's number, which is 6.02 times 10 to the 23rd. 1 mole of anything is equal to that number of the item that you can count. So 1 mole of glasses would be 6.02 times 10 to the 23rd glasses. Chemists generally don't count glasses. We like to count things like molecules, ions, or atoms. And so we can use that definition of the mole to easily convert between that item that we're counting and 1 mole. And we did a few practice problems like that in the previous video. So that's useful to us, this new unit of the mole, because when chemists count things like atoms, molecules, and ions, they're pretty small, and we need a unit to help quantify something that is so small when we're counting so many of them. But one thing that we haven't talked about yet is how can we use, or can we use, this unit called the mole with regards to how much an atom or a molecule weighs? And the answer to that is yes, we can. And we can do that by using the second definition of a mole, which is going to involve the mass of an element or a molecule in terms of grams. So how does that work? How is it going to be using the mass of those species going to be used in concert with 1 mole? So you're going to need your periodic table for this part of the of my little video. On the slide, I have two examples of substances, both of which equal 1 mole. So I've got some sulfur, powdered sulfur here, pretty stinky, and I have some carbon. Both of these pictures show 1 mole of those atoms. So in this first picture, I have 6.02 times 10 to the 23rd atoms of sulfur on the left-hand side here. On the right-hand side, I have 6.02 times 10 to the 23rd atoms of carbon. So both pictures show 6.02 times 10 to the 23rd atoms. But what do you notice about the masses of each of these atoms? The masses, even though they're both 1 mole, they're both 6.02 times 10 to the 23rd atoms, the masses of these species are different. And they're different because they're different species. They have different numbers of protons, neutrons, and electrons. And remember that the atomic mass of an element is due to numbers of protons and neutrons. So we can use the atomic mass for an element, and we're going to do it for a compound as well, but let's start with an element. We can use that atomic mass for the element to say something about how much 1 mole of that element weighs. So looking at both of these pictures, I already told you they are both 6.02 times 10 to the 23rd atoms, which is 1 mole. The sulfur, that turns out to be 32.07 grams. Now take a look at your periodic table for sulfur. What do you see the atomic mass is for sulfur from your periodic table? You should see that it is 32.07 atomic mass units. So it's the exact same number, just the unit is different. So 1 atom of sulfur weighs 32.07 atomic mass units. If I had a whole mole of sulfur atoms, which is 6.02 times 10 to the 23rd sulfur atoms, the mass of that 1 mole of sulfur atoms would be 32.07, not AMUs, but grams. And that's really, really helpful for chemists because when we are in the lab doing experiments in a normal semester, when you're in the lab doing experiments, you don't count atoms on the scale, you weigh them out in terms of grams. And so now we have a very handy way to relate a mass that's easily manipulated in the lab in terms of moles. Let's look at carbon. Let's look at our carbon example. We said that this on the right-hand side is 1 mole of carbon atoms, 6.02 times 10 to the 23rd. The mass of 1 mole of carbon atoms is 12.01 grams, which is the exact same number for the atomic mass of carbon. The unit is just changed from AMUs to grams when we're talking about moles. And so that's what's great about the periodic table and the way it was designed, is that you can use the atomic mass for each element in terms of grams to say how much 1 mole of that element weighs. So let's look at hydrogen. Look at your periodic table. Hydrogen. Hydrogen has an atomic mass of 1.01 AMUs. That also means that 1 mole of hydrogen would weigh 1.01 grams. And so we can then use that information in calculations like this one right here. We can convert between grams and moles using what's called the molar mass of that substance. We were just talking about hydrogen. Here, let's stick with carbon. Let's say we have 0.58 grams of carbon, and I want to know how many moles of carbon that is. So I start this dimensional analysis problem just like I would any other. I write down what I'm given, the 0.58 grams. I'm looking for something in terms of moles of carbon. And to go from grams of carbon to moles of carbon, I don't need to use Avogadro's number because I'm not counting numbers of carbon. I'm going from a mass to moles. And so that's where I'm going to use the molar mass of carbon, which you get from your periodic table, which you'll always be able to use for quizzes and exams and practice problems. You look at your periodic table and you see for carbon that the mass is 12.01. One atom of carbon is 12.01 AMUs. 1 mole of carbon is 12.01 grams. So I can use that information from the periodic table written as a conversion factor, written so that my gram units cancel. I'm left with moles carbon in the numerator, which is great because that's what I'm looking for. And so then doing that division, I get 4.8 times 10 to the negative 2 moles of carbon. So we can go from grams to moles. Let's do something similar with argon. We want to know how many grams are in 0.623 moles of argon. You write down what you're given. Give yourself some space to work the problem. Write down the unit that you're looking for. And then in that space, write down the appropriate conversion factor, which in this case is going to be the molar mass of argon. So you look at your periodic table and you see that for every 39.95 grams of argon, that atomic weight is 1 mole of argon. So you write that appropriately so the units cancel. And then doing that multiplication, you should get to 24.9 grams of argon. So now that's our second and final definition of a mole. We can now use the molar mass of a substance, which is the same number as the atomic mass of an element. You just change the unit from AMUs to grams. That atomic mass is how much 1 mole of that substance weighs in terms of grams. So that's pretty handy for chemists. It's so handy and exciting for chemists that they actually have a holiday celebrating this unit called the mole. So it's called Mole Day. And you can, here I have the website here, so you can take a look at it if you'd like. But Mole Day is celebrated on a very specific day, specifically on October 23rd. You can probably guess why that is. And it's celebrated from 6:02 in the morning to 6:02 at night. You can probably guess why it's that time as well. In chemists, you know, we need any kind of excuse to have a party. Every Mole Day has a theme. My favorite was May the Moles Be With You in 2015, but I also kind of like this Despicable Mole Me, because I kind of like the Minions. I was really sad that the Minion movie got pushed back. I guess there's another Minion movie coming out. It was supposed to come out this summer, but it'll be next summer, I guess. But like I said, any excuse that chemists can have to celebrate this great concept called the mole. It's also a great way to do science outreach and STEM outreach to middle and high schoolers. So people get really excited about the mole. There's even a holiday for it. I'll let you look that up. So all of this is to say that the mole is a very, very important number or concept that chemists use. We're going to use it throughout this course. In the next few videos, we're going to be doing some more practice problems with this concept of a mole with regards to Avogadro's number, 6.02 times 10 to the 23rd, and with regards to the atomic mass of the substance that you're dealing with.